here's my graph of cos. Okay. Now, you face the same problem of having to restrict it in some way. The question is, what will be the most useful way? Unfortunately, the most useful way ends up with a somewhat confusing result, because you might start off in exactly the same way and say, I want acute values. Acute values make sense, okay? So you pick these guys. There's 0 to pi on 2, acute values, okay? But now you certainly cannot do what you did with sine, right? Because if you were to go the other way, you're including a turning point there, right? You're including a portion of the graph that is not 1 to 1. Namely that portion, okay? So we're busted. We can't go from negative pi on 2 to pi on 2 like we did with sine. Instead, you have to go forward. So you get this domain, 0 to pi, okay? Now this is interesting, 0 to pi. Believe it or not, this accounts for one of the most irritating problems you've been dealing with over the last 2.5 years. Namely, when I give you some measurements for a triangle, okay? For instance, suppose I say to you, so I just have to think of a good example. If I gave you some measurements on this thing, okay, and said maybe, oh, I don't know, this is 32 degrees, and this is, let's call that 45 meters, and let's see, let's make this, what does it look like? 61 meters, something like that. And I said to me, can you tell me what this angle is? Can you tell me what the angle is? Okay. Now, have a look at the information that I've given to you. What will be your first reflex for how you would find theta? You'd use the sine rule, because the information that you've got matches up to A on sine A, B on sine B, okay? Now when you put all of this information in, right, you end up with a problem, because you'll end up with, in this case, sine theta equals some stuff, okay? And then you get your calculator out and you say theta equals, and you say sine inverse, okay? Now you'll get some angle out here, but then there's a problem. What's the problem? The problem is, you'll get some answer. I can guarantee you will get an acute answer, right? Because think about this. If I used sine inverse can only possibly give me acute angles, because that's the way that I restricted it, right? Admittedly, it can give me negative acute angles, but I'm not going to give it a negative ratio because of the way these sides relate to each other. So it'll give me something acute. Okay? But of course, you know that theta might not be acute, right? And we give a name to this problem. What's the problem called? The fact that it could be something, or it could be something else. What's the other thing it could be? It could be 180 pi minus that acute angle. It could be the obtuse version of the same angle. We call this the ambiguous case, right? Now, having a look at this, you can actually tell what the angle will be, because you can know the ratios of the sides, you can add them all up and so on, okay? But this ambiguous case business, right? It comes directly from here, okay? The sine rule has an ambiguous case because we made it have an ambiguous case. Now, when you're using the cosine rule, there is no such problem. Can you see why not? Can you see what's going on? When we define cos inverse, right? Because we can define it from 0 to pi, it includes acute and obtuse angles. So you use the cosine rule and you never get it wrong. There's no ambiguous case for the cosine rule. Does this make sense, right? It's because the angles that the cosine inverse function can give you go all the way from 0 to pi. Whereas sine inverse is kind of stuck. He's like, well, I give you what I can give you. It's only stuck in there, okay? So that's what cosine inverse is going to be restricted to. So what's it going to look like? Now, because its domain is all positive, therefore the range of cos inverse will be all positive, right? So very quickly, it'll look like this. Okay, now let's think back. For me, let me go back 11 years. When I was learning inverse trig for the first time, okay, and I was trying to graph these functions, I got these, sine inverse and cos inverse, I got them massively confused because there's so many different variants on how you can draw this. For instance, you can draw this, or you can draw this, or you can draw this, or you can draw this. Okay, and the longer you stare at them, the more confusing it gets. Okay, so here's the way that I think about it. Sine, right? The portion that we've chosen, is it increasing or decreasing? It's going from -1 to 1. It's increasing, right? Therefore, when you reflect it, it's still increasing. It's still increasing. Okay? So that's how I remember this one, that's sine inverse. It must be increasing. Okay? In exactly the same way, what portion of cos have we chosen to restrict? We've chosen a decreasing part, right? So when you reflect it, it's still decreasing, right? So sine is increasing, so is sine inverse. Cos is decreasing, so is cos inverse. That's a helpful cue for you to remember it. Okay?